So today, what we're going to talk about is all about binomial theorem. So first, before we dig in about binomial theorem, let us have an introduction first. So what is a binomial and what is an exponent? So a binomial is a polynomial with two terms, meaning it has a first and second or last term. So for example is 3y plus 2x and 6x minus 5y. So in both binomials, for the first term are 3y and 6x, while the second term are 2x and negative 5y. Next is exponent. So exponent says how many times you use something in a multiplication and how many times you have to multiply itself by itself. For example is 3 squared. So since the exponent is 2, then we will multiply the base or the 3 to itself twice. So 3 times 3, so the answer will be 9. The next example is a plus b squared. So we will times a plus b by itself twice since the exponent is 2. So by FOIL method, the answer will be a squared plus 2ab plus b squared. So number 2, what is binomial theorem and what is Pascal triangle? So now we will learn all about binomial theorem, or what we call binomial expansion. Binomial theorem describes the algebraic expansion of powers of a binomial. So it is simple as when we multiply a binomial by itself and how many times depending on its exponent. So in order for us to get the number of terms of an equation, we will use the formula n plus 1, where n is the number of exponent. So if the exponent of the binomial is 5, then the number of terms is 6. So like x plus y raises to 5, we will use n plus 1, that it will be 5 plus 1, and then the number of terms is 6. Before we dig into the examples, we must first know all about Pascal triangle. A Pascal triangle is a triangular array of binomial coefficients. Each row of the triangle describes the pattern we will use in the whole equation with the use of exponents. So if we have 0 exponent, we will get 1, because any number raised to 0 is 1. And if we have 1 exponent, we use or multiply the numbers in the row as a coefficient, and if we have the exponent of 2, we'll use the row 1, 2, 1, and as well as the others. We can simply make a Pascal triangle by start with the number 1 and add the 2 consecutive numbers to get the number for the next row. So for number 3, the steps in expanding binomial theorem and its examples. So number 1, step 1 is raise the exponent of the first term of the binomial in descending order every single term of the whole equation from left to right. Number 2 is raise the exponent of the second term of the binomial in ascending order every single term of the whole equation from left to right. So number 3 is put the coefficients in each term using the Pascal triangle pattern. And number 4 is we will simplify the equation. So for our first example, as you can see, we can see the x, or the first term of the binomial, its exponent is descending, while the second term of the binomial is in ascending order. And you can also see that we use the coefficient 1, 3, 3, 1 because the given exponent is 3. So we will use the row number 3 in the Pascal triangle. So 1 quantity x raised to 3 times y raised to 0 plus 3 quantity x squared times y raised to 1 plus 3 quantity x raised to 1 times y raised to 2 plus 1 quantity x raised to 0 times y raised to 3. So if we will simplify that, or we will times the variable and coefficient, the answer would be x cubed plus 3x squared y plus 3xy squared plus y cubed. And also, as you can see, we have the exponent of 3, so it is true that if we add it with 1, it will be the number of terms. So for example number 2, we have 3x plus 2 raised to 5. Again, we will use the descending order for the first term while the ascending order for the second term. And since we have the exponent of 5, so we will use the row 5 in the Pascal triangle. So it will be 1 quantity 3x raised to 5 times 2 plus 5 quantity 3x to raised to 4 times 2 raised to 1 plus 10 quantity 3x raised to 3 times 2 raised to 2 plus 10 quantity 3x raised to 2 times 2 raised to 3 plus 5 quantity 3x raised to 1 times 2 raised to 4 plus 1 quantity 3x raised to 0 times 2 raised to 5. If we simplify first the first and second term of the binomial, it will be 1 quantity 243x raised to 5 plus 5 quantity 162x raised to 4 plus 10 quantity 108x raised to 3 plus 10 quantity 72x squared plus 5 quantity 48x plus 32. And if we times those in the term, the answer will be 243x raised to 5 plus 810x raised to 4 plus 1080x raised to 3 plus 720x squared plus 240x plus 32. For our third example, we have 2x plus y squared. So it will be 1 quantity 2x raised to 2 times y raised to 0 plus 2 quantity 2x raised to 1 times y raised to 1 plus 1 quantity 2x raised to 0 times y raised to 2. So those with 0 exponent will be times by 1. So the answer for number 3 will be 4x squared plus 4xy plus y squared. So for our fourth example, it's x plus 2 raised to 7. So we will use the similar steps that we do for the first 3 examples. So we'll have 1 quantity x raised to 7 times 2 raised to 0 plus 7 quantity x raised to 6 times 2 raised to 1 plus 21 quantity x raised to 5 times 2 raised to 2 plus 35 quantity x raised to 4 times 2 raised to 3 plus 35 quantity x raised to 3 times 2 raised to 4 plus 21 quantity x raised to 2 times 2 raised to 5 plus 7 quantity x raised to 1 times 2 raised to 6 plus 1 quantity x raised to 0 times 2 raised to 7. After simplifying the exponent and multiplying inside each term, it will be 1 quantity x raised to 7 plus 7 quantity 2x raised to 6 plus 21 quantity 4x raised to 5 plus 35 quantity 8x raised to 4 plus 35 quantity 16x raised to 3 plus 21 quantity 32x squared plus 7 quantity 64 x plus 128. So after final simplification, we will get x raised to 7 plus 14x raised to 6 plus 84x raised to 5 plus 280 raised to 4 plus 560 cubed plus 672 squared plus 448x plus 128. So for our last example, we have fraction in our binomial, which is x over 2 plus 2y raised to 5. We'll also use the same method, but we have a fraction. So it will be 1 quantity x over 2 raised to 5 times 2y raised to 0 plus 5 quantity x over 2 raised to 4 times 2y raised to 1 plus 10 quantity x over 2 raised to 3 times 2y squared plus 10 quantity x over 2 squared plus times 2y cubed plus 5 quantity x over 2 times 2y raised to 4 plus 1 quantity x over 2 raised to 0 times 2y raised to 5. Since it's a fraction, the exponent will be distributed in both numerator and denominator. So it will be 1 quantity x raised to 5 over 32 plus 5 quantity 2x raised to 4y all over 16 plus 10 quantity 4x cubed y squared all over 8 plus 10 quantity 8x squared y cubed all over 4 plus 5 quantity 16xy raised to 4 all over 2 plus 1 quantity 32y raised to 5. So if we will simplify it more further, it will become 8x raised to 5 over 32 plus 5x raised to 4 y all over 8 plus 5x cubed y squared plus 20x squared y cubed plus 40x y raised to 4 plus 32y raised to 5. So before I end this video, I will have a quote: start wide, expand further, and never look back. Thank you for watching.